everybody, and welcome back to John's Workshop. And in this video we're going to be doing another one in the Workshop Tips series, and we're going to be looking a bit more closely at chemical bluing, chemical blacking. So that's what this one's going to be about, and we're going to look into this because it's probably one of the most frequently asked questions I get on the channel by people who watch a video, see me chemically black something and then say, what do I use and how do I do it? So I get lots of those types of questions, so I thought I'd do a video on it. But rather than just talk about what I use and how I do it, I thought we'd look into the process in a bit more depth. So we're going to talk about what is chemical bluing, chemical blacking, why would we do it, how do we do it. There are other methods available, so we're going to dig into some of the other methods of creating that same thing. And that's what you would physically see on a commercially bought tool. If we're going to, it's mainly tools in the workshop that we're doing on this. And then at the end, we'll look into what I use in terms of product and what I think of it. So without any more waffling, I'll clear the bench and we'll dig in and start going through it. Okay, so we're at the bench, which is a novelty, and it's clean, which is another novelty. So we've got some space. And we've laid out some things that have been blacked, or blackedized as it's sometimes known. And these have been blacked or blackedized or chemically blacked or just made black by different methods. There are different ways of doing this. So we'll just ignore these for a minute because they're all commercially bought items. We'll just look at what's left on the table. These are all things that I've made that I've chemically blacked, and we'll talk about what I use later. So ideal for fixturing, tooling, spindle tooling, lathe tooling, any kind of tooling or fixturing really in the workshop. And why do we black them? Really two reasons. The main one being corrosion protection and the secondary one being visual appearance. So obviously these look very similar to commercially bought items, which is nice to have when you've made something yourself in the workshop. So what is chemical blacking? So I'm going to talk about chemical blacking for now. So again, ignore the commercial items because they could be slightly different. So chemical blacking or bluing is a cold chemical process that basically converts the very surface of the material to a different standard through the chemical reaction. So what you're doing, it's effectively it's a corrosion process, but it's a chemical corrosion process in a controlled manner, and the end result is the colour change visually. But if you looked into the surface itself under a microscope or through a section, you would see that for a few microns or a tenth of a thou or so deep, you have changed the surface structure of the material, which is what gets you the corrosion protection that you get, because the surface of the material is now different when it's presented to moisture or humidity. And that's why this process works really, really well with, in a damp or a home workshop environment. When we look at a commercially bought item, and I've got some Sandvik tooling here, as I said before, looks very, very similar, but it's not similar because it's done by a completely different process. And a lot of these sort of high quality, high end tools will go through almost a dual step process using lots of heat. The first one being a plasma nitriding process, which is done at very high temperatures using plasma in a nitrogen environment, nitrogen rich environment, in fact pure nitrogen, where the tools themselves or the units, whatever they are themselves, will absorb that nitrogen into that surface layer, which changes the properties of the tool, changes its stress and strain properties, its resistance to vibration and chatter, and all sorts of things through that process happen to the material itself. And then that will be followed on by a process called physical vapor deposition, sometimes abbreviated to PVD. So you might see something that's got a PVD coating on. That is what these have had that give them this black appearance. It's the PVD coating following on from plasma nitriding that make these look the way they do and make these behave much differently to if I'd just got a lump of steel and made something that looks like this and chemically blacked it where I'm not getting those properties changed in the substrate of the material. So we've talked a little bit about two different ways of doing it. There's a third way of doing it, which is to heat your components up red hot and chuck them in a bath of oil, and that will also give you the black appearance. It will give you some corrosion protection. In my opinion, it's not quite as good for a couple of reasons. One is you'll end up with more of a scaly finish, whereas these, you know, if you want something that you're butting parts up to and you want it to be accurate without any kind of scale or flaking, you don't get that with the chemical bluing or chemical blacking. And secondly, if you've got something like this, for example, that's a piece of Swiss cheese, if there is any residual stresses in that material and I heat that up to cherry red and dunk it in a bath of oil, yes, it might look great, but unless I've dunked that in a bath of oil absolutely square on, and it's quenched it a bit like a hardening process at different rates, there is every possibility that I'm going to change the shape of this, which is the last thing I would want if I was wanting it to be like an accurate mandrel or an arbor or a rail for a machine tool or something, you know, a finely machined location such as the tool holder, that kind of thing. There is always that chance you're going to get movement with the heat. So the cold process, you don't get that. You just get the straightforward conversion of the surface, which I think for tooling is a much better option, albeit it takes a lot more effort to do it this way, and we're going to move on to how to do that very shortly. I think there's a third one. So this is a commercially bought drill drift. It's not something I've made. It's got a kind of black to it. It's not going to have been plasma nitrided, I can pretty much guarantee, based on the price of these things, but it's probably been through some sort of PVD style coating treatment. I would think it won't be chemically blacked or blued in the way that I do my stuff in the workshop. And then finally, while we're doing this bit of a round, and I know I've done this gag many times, but it's always worth repeating, there is another version of chemical black which is absolutely useless for tooling in the workshop, but it's quite good for the people that use the tooling. Okay, so how to chemical black? There's some stages to this, and one of them will vary depending on what you're using, the chemical you're using, but largely four stages to the process. Stage one is degrease, probably the most important stage. If you don't do this right, you won't get a good result. Simple as that. Parts need to be absolutely spotlessly clean without any grease or oils at all, and that includes the grease and oil from your fingers. So this is wearing of gloves and using some form of degreaser. Now, I've always used meths up until recently, which is quite laborious, you know, tipping it on a rag, wiping, that kind of thing. I've now started using this gunk, which is spray on, leave on, wash off. Getting good results so far with that, much easier. So you've got your part degreased. The next thing is you do your chemical bluing or blacking process. Now I use a dilute solution of blue. This solution in here is probably 2 years old, and I just use it and use it and use it, and you'll see at the bottom of this there is some or whatever you want to call it, some dross from the process, which is small amounts of metal that get removed, but it sinks to the bottom. Every now and again I'll filter it out and just get clean stuff. So you chuck your part in here 10-15 minutes, you take it out, you drop it into water, just normal water. I don't use tap water, I use rainwater. I don't know whether that makes any difference, and all that does is neutralises the chemical reaction on the surface of the component. You then take it out of the water almost immediately, dry it instantly. If you leave any water on the surface, you'll get rust almost straight over, flashed over, so you've got to be really quick, get it dry. I use the dilute solution because it's dead easy. Chuck it in, forget about it for 15 minutes, take it out, drop it in there, a couple of minutes or a minute, just give it a rinse, take it out, dry it, oil it. Not difficult, doesn't take too long. The bluing, rinsing, oiling bit is minutes of time. It's the degreasing that takes the effort. Okay, we're going to clear this away and I'll bring out the chemical that I use and show you that and talk you through what I think of it. Okay, so this is what I use. It's called black oxide solution and it's come from a company called Carswell Europe. I'll stick that on the screen somewhere. It's made in the United Kingdom, sold in the United Kingdom, as I said, and it says on the bottle here, used as a submersion product, diluted with water. I think it was 10:1 ratio, 1 part of this, 9 parts water. 10 parts water, and or apply by hand using a sponge, brush, that kind of thing. So that's nothing else to say. That's what it is. That's where I got it from. The one thing I would say about it is I find it utterly bizarre. This would have come with a data sheet with it, and I'm fairly sure that data sheet would have said don't get this stuff on your hands, don't splash it in your eyes, what to do if you do splash it in your eyes. I've lost that data sheet, got no idea where that went. That probably went in the packaging when I threw it away. I find it utterly bizarre that in this day and age you can actually get a bottle that doesn't have any precautions written on it whatsoever. So what I would suggest is get a pair of these on when you're using anything like this. It's a chemical at the end of the day. Wear some safety glasses if you think you're going to get splashes. Just be careful. As I said, I can't remember what the precautions were for this, so yeah, just be careful with the stuff. It's obviously not nice what's in there, but in terms of am I happy with it as a product, yes, couldn't be more happy. I mean, I bought this is 3/4 full. I bought that 3 years ago, and I'm just using the same stuff you've seen in the tray. I just don't have to change it. It just lasts forever. This will probably last me another 5, 6, 7 years, probably even longer, I don't know. So that's what it is, that's where I got it from. Can I recommend it? Absolutely. The only word of caution is don't throw your data sheet away, because obviously they've missed a trick there and not put any of the warnings on the bottle, which I find absolutely bizarre in this day and age, as I said. So there you go, that's what I use and I would highly recommend it. And as for the other chemical black, can I recommend that? Highly recommend it. In copious quantities, no precautions needed. Knock yourself out. Well, there we go, that gets us to the end of this tips video. I'm calling it a tips video. I suppose there are some tips in there around the use of chemical black and what it is and how to use it, why to use it, and just some of the experience I've had of that particular product. You know, I can talk to that very well. I've used it quite a lot, and as I said earlier, I can highly recommend it. In fact, both of them. So I hope you found that useful, and hopefully for some of the frequently asked questions I get now, I can just point them to this video rather than having to keep typing it all out each time in sort of responses and answers and comments. So that will be handy for me as well. So I hope you've enjoyed that, and I hope it's given you a bit more of an insight into what the blacking process is, both industrial and sort of home shop, cold bluing, cold blacking, that type of thing. And hopefully one or two of you will give it a go, because it's not difficult, and as you've seen by the stuff I do, the end results, both corrosion resistance is absolutely brilliant. You know, I would say 10 times improvement, if not more. Everything I've chemically blacked in here, and this is a really aggressive environment in this workshop, lots of humidity, lots of moisture. I don't see any rust on any of those bits. I've got other bits of steel in here in my stock bins down under the bench. Anything I put in there that's a carbon steel just goes red rusty in days in this workshop. Anything that I've made from that and then subsequently chemically blacked gets no corrosion on it at all. So it's in the same place. So what better sort of proof can you have that it is good at what it does? So it really does help from a corrosion protection perspective, and I think the bits look really good when they're done. So as I said, hope you found that interesting. Thank you to the viewers and subscribers, and thank you to the new subscribers that have come along, and we'll join you all very soon on another video when we'll be making something else.